In this problem, we want to find the minimum value of 1/2 x plus square root of x minus 3 squared plus 3. And we'll be using the geometric approach. First, by observing, we realize that this looks like a Pythagorean theorem. So we can use triangles to solve this problem. We can start off with a basic triangle, non-special. So we can just look at this as a triangle. And this is not a right angle. We can call this triangle as ABC. Now, this represents a right triangle. So we're going to construct a right triangle here. How do we do this? Well, we can construct the height from A to BC. Call this point as H. So we want this point to be x minus 3. And then, to get the square root of 3, well, if we let the whole side BC as equal to x, well, BH then will equal to 3. And then AH here, well, we know that this is square root 3. And this shows that this ABH triangle is going to be a special right triangle. So it's a 30, 60, 90 right triangle with angle B equal to 30 degrees. And now, how do we get a 1/2 x? Because we already know that AC will equal to square root of x minus 3 squared plus 3. To get the 1/2 x, well, since BC equals to x, we can just use another 30, 60, 90 right triangle. So we can let this also equal 30 degrees. We let angle CB, call this point as D. Angle CBD is also 30 degrees. And angle BDC is going to be 90 degrees. So this will give us that CD equals to the 1/2 x. And the question will just ask us to find the sum of AC plus DC. How do we find the minimum value of this? Well, first of all, let's observe the problem again. So, what points on here are fixed? Well, we start off with triangle ABC. And then the triangle ABC, well, B is a fixed point. And then, we starting from B, we can know that A is also a fixed point, because we know that we can find out the length of AB, which is going to be 2, 3, by the right triangle here. So, with A and B are fixed, we know that angle ABC and angle DBC are also fixed. Both are 30 degrees. And we also know that angle BDC must equal to 90 degrees. However, point D is not fixed, and neither is point C. So we have to make sure that we have angle CDB is equal to 90 degrees. How to find a minimum value of AC plus DC? Well, if we observe AD as 2 points, well, C is going to be the point in between them. I'm going to find a length from AC and DC. So if we just take a random point C on BC again to observe what changes, well, first, if you let C equal to here, well, it will look like this. If you let this equal to C prime, and then it'll become AC plus CD. And in this case, well, notice that it gets shorter because A, C prime, and D prime gets closer to being collinear. So the shortest is going to be when they are collinear. So in that case, it'll look like this. Got D prime prime and C prime prime. And since this is just going to be another 30, 60, 90 right triangle, well, the minimum value of this will just equal to A and D prime prime. In this case, will equal to 2 root 3 divided by 2 times root 3, which is just going to be 3. And we know that this is the minimum value because this is the length where AC prime and D prime prime are collinear. And a straight line is going to be the shortest distance between 2 points. So that's how you solve this problem.